Hello everyone, welcome back. So today we are going to discuss about the permutation question, and this video is a second video where we will learn the second technique. So if you missed my last video, you can go and review where we discuss the same question, the permutation, how to solve a permutation, with a different technique, where we will make a complete tree, and then after that from the complete tree algorithm we figure it out one by one how to convert that algorithm into the question's answer. Today what I'm going to do, it's a very different technique. It's recursive because you need to generate, like we have only three elements and we need to generate the input. So it's easier to go with the recursion because recursion is unlimited and you can make anything what do you want. So I will go with the different technique in this one. What is that technique? First, before going to that, so this problem generating a permutations or anything around this, most of the time sometimes the question will be around, they will give you a string and you need to make from that, or maybe the array of integer. So what we will do in this one, I'm taking this as an array of ints, but you can do the practice with strings also. It's pretty good to understand, and then you can learn more about the string built-in functions which you need to use in these type of questions. So okay, it's time to start. So basically the question is, we need to generate an input. So this is our input 1 2 3, and the expectation is we will go and return the array list of enums, not enums, numbers, and that will be the permutations. So in case of it's ABC, then we need to return ABC, ACB, BAC. It's like this, and if it's then 4, then 4. So in this technique, what we need to do, once you figure it out, okay, this question is more towards recursion, you need to go with the recursion. It's good. And we discussed last time, if you can make a tree, it's pretty easy. You can easily figure it out, the solution, if you can make a tree. So now what we will do, we figure it out, it's a problem of a recursion. Now you need to think, okay, just like divide, you need to divide and then conquer. It's not divide and conquer, but still we will divide and then we will take back. So my question to myself, okay, if I have a one input, if I have a 3, what will be the answer? And the answer is 3. Okay, then what will come the next is, if I have an input 2 and 3, what will be the answer? So we know 2, 3 and 3, 2. Okay, still I can take one more example, but I will not write a full. You can understand from here the same. And 1 2 3, so this is our input. Now our output will start from 1 2 3 and go on until 6. Okay, can we see a pattern here if I want to make something like that by using this? So yeah, to me I can. How? Okay, so once I have one input, I know I need to return the same. So 3 means 3. So it's kind of a base case. So we will say our base case is also one input, or if it's empty, that is the edge case. So we will return the empty, or it depends what the interviewer wants. So here 3, I will return 3. But they're saying once we have 2 3 input, you need to return 2 3 and 3 2. So if I think from the recursion perspective, okay, I've broken down all the input until 3. If I want to come back from here, so like for example, I started from 1, then I broken down 2. So it's like a recursion, started from here. So this is first recursion, then I started my second recursion, and then this is my third recursion. Now in this recursion, this is the base case. I'm saying, okay, you need to return me 3 back. So it's saying, okay, now this is our result. If I want to make this 3 to 2 3 and 3 2, what I need to do, I can see easily one thing. The function which invoke the next function and we are giving one less input, I am saving that input 2 and I need to insert in the start and in the end, like so 2 3 and 3 2, or maybe in simple words what we can say. So once I have 3, I got back 3, okay, and now my stack, the recursion is around 2 and this is the return function list from the base case. What I need to do, I need to put 1 time 2 here, 1 time 2 here, and how I can see 1 time when I will input here, I need to save that list. So I will make 2 and 3 as a separate and then 3 and 2, okay. Then now this one is returning back to our last input, the inner recursion. So I have 1, only focus here, 2 3 is my 1 input and then the second which I got from here 3 2. Very simple. Now what I want all this information which is going by, we are going to make by 1. So I need to do one thing only. Insert 1 time here, it will be 1 2 and 3. Then insert 1 time here, it will be 2 1 3. Then insert 1 here, it's 2 3 1, and same 1 time here, 1 time here. So it's pretty easy. Only you need to do 1 time sit down, think about that, broken down all your inputs until the 0 case, the base case, and then once you are coming back from the base case, take one value and then check and then see, okay, if I insert on this side, am I getting something what we really want? Yes. Okay, if I insert on this side, yes. Sometimes the questions are different, but again you can see, okay, only maybe there is a, for example, question which is not like this, which is different, but you can see, okay, I will break down until base case. Now once I'm coming back from the base case, take the base case value and you need to only always insert at 0. Okay, if I insert this value at 0, is it looks like the same for 2 input answer? Yes. Okay, take this, come back. So you need to think, take to until 0 and then come back and then try to make some kind of a graph, the algorithm, the calculation. So I will say this is my calculation, I know this is my result. So kind of we can say I can write a pseudo kind of a trace of a pseudo code, or maybe we can write a pseudo code also. So we already figured it out. I have a function which is taking the array of nums 1 2 and 3. Okay, my base case is somehow when I have only one value, so I need to figure it out how to generate the one value. Now there are two things. I can send this as a sublist. So every time I'm sending this one list less. So for that my algorithm will be fun a nums int of array. Okay, if nums dot size is equal to 0, which means now we have this case, return nums. Okay, I return this. What about else? Otherwise, because I did return, now I need to make sure my algorithm looks like this. So before going ahead with this approach, I want to trace something, so it will help us to make the algorithm. So I am taking this example 1 2 3. Consider this is our function call. Okay, there is no base case for now. What I want to break down this. So I'm saying, okay, save my first index value somewhere. So I'm saying, okay, value maybe a, and I'm saying, okay, this is my index, so save which is available at 0. Okay, now a have 1. What's next? List. Okay, maybe I will do this later. Now next, what I want again to call recursion. So again I am calling this function and this time when I'm calling this function, I'm saying call this n with 2, 3. Just like how we discussed. So I break down, I'm not thinking about how to make this input. I'm only thinking about how to break down. So every time when you have a problem, you need to break down. This is the same approach. Okay. Now I did breakdown here. Again, it's not base case, and we already wrote this. So again, a is n of 0, which means now it's 2. Again, I need to call this function breakdown. Now this time it will be only this. Make sense? So I have a list. I am breaking down until the value here. Now this is a base case. We are saying, okay, once you are a base case, return me. So once it's going to return the value, what will be that value? It's only 3. So I have a value here 3. So I will say okay, value list 3. Make sense? Now what is the next step? N of 0 is 2. So and at this stage, what I want to achieve, I have 2, I have 3, I need to put one time here and one time here. How we can do? We can try. So it means I need to somehow run this thing until 2 times. And what is a good, so I think we can run according to, so our list sublist is 2, so I think I can say I in 0 until n dot size. So this is going to run 2 times. Okay, what's next? I created a one more list of lists. Okay, what I want answer dot add list dot insert. Basically insert in Java and Kotlin we have same method, add on, we need to give an index and then the value. Maybe in your language there will be an insert method, but I am basically doing, okay, list, take this, insert at I, what you need to insert a. Okay, so once I did this, what will happen? List currently is 3, I is 0, so 0 put 2, so now this is 2 and 3, this is going into list. Yeah, there is, because it's a reference, so it's changing original ones, we will discuss that later, but take it as a pseudocode. Then next time loop again needs to run, because n dot size is 2, so it needs to run 2 times, 0 to 1. Now what will happen? We have still 3, and this time I am saying put this at 1. So we achieve this. Okay. Now we need to run one more time. If that algorithm, this pseudocode works here, it means we achieve for n. So now in this case, my list will be looks like this: 2, 3, and 3, 2. So basically, I am getting now from here this answer. So what we can do here? Now I want to put 1 where one time here, one time in between, one time in the last. Then take this first and then last. How to do this? So first we need again some like this same. I created a new list. Now we need to run again loop. But this time the one point which we need to understand, this list has 2 values. Before that we have only one, so one loop is enough. But now this time we have 2 values, and maybe if I have 4, 1, 2, 3, 4 for the permutation input, then it means maybe I have at this point 6 values. And so in this case there are 2 things, we figure it out. Okay, if I want to put 1 to at 0 and 1 at 2, we can achieve the same, but we need to add to every answer. So for that I need a one more loop, I in 0 until n dot size. So this one is going to run until dot size. Here n is 3, so it means 0 1 2. So 0 1 2 means this loop is going to give us the index. So first time add 0 here, then 1, then add 1 at a 1 position. So this one is done. The second loop is I need to put that one on each return the answer. So in that case I will say okay, for you have L in list. Okay, but I think I need to move this above and this down. Why? Because this one will run 3 times. This will run against the 1 2. So basically what happened, this time it will run for 2 3 3 2, then 2 3 3 2, because the bigger loop which I need to insert, I need to do. So this is my main function which I want to do, like insert at 0 1 and 2, and at which value, this value 2 3. So I need to reverse only. So my loop will be for L in list, and the second loop is for I in 0 until n dot size. Now we are good to go. So what I will say okay, answer dot add L dot add I, and first value is A. Done. And this is our algorithm. We are done. So this will work, 100% sure. Now I will write again a proper pseudocode here. We will trace and then we will write in the end the proper algorithm. So this one is done. What's next? I'm saying okay, value save, maybe 8. Please give the good name, but for now I'm taking only this. Nums of always 0. Then again I'm getting the list, which is again calling the same function, but nums dot split. I'm not sure what function is, but in the pseudocode the mean is I want only the from 1 to end nums dot size. So don't take this as a literal like the original function. My assumption is what this will do, this function will divide num dot split into 2, and I will return, or maybe I think the sublist is a good method. I use one. So sublist from 1 to nums dot size. So my expectation is I will call this again this function. So this time if there is a 1 2 3 array 1 2 3, I will do now 1 2 2 3 only, and the next time sublist again of that 2 3 is 3 only. Then once this is done, what will happen, we have list, I have answers list of integers. Okay, this is done. Then we have a loop for L in list, for I in 0 until n dot size, and then answer dot add L dot add I A, and return answer. So this is our pseudocode. We can run this. So I'm sorry I'm repeating again, but it's pretty important. So every time when you have an input, try to divide and think, okay, I need to go until base case. What will be my base case? Maybe you can go until end, or maybe you can go until maximum. So in this question, I decided to do the experiment to go until base case, which is 0. So I say okay, this is the value. I assume now I have this value input, then assume this value. Okay, if I have only 3 input, I need to return 3. Okay, if I have a 2 3, I need to return this. Can I make this? Yes, I can make this by writing. So Then I have a full value, so I am returning this. So it's like kind of a in mostly it happen in dynamic programming. You have the you always make the decision. You will go until 0, and then from there you calculate the answer, and then you save that answer, and you will go every time to the next step, and you will take the help from the last step. The kind of what we are doing in the same way. So every time saying, okay, this is my last answer, take this, and my now current one, insert everywhere. So now we will execute this against this value. So I am saying, okay, A, call 1, 2, 3. Is it a base case? No. Saving A is 1, num as 0 is 1. Then list, and again call the function A. This time call with the sublist from 2 to 3. Okay, again this, not base case. This time A0, num 0 will be 2. Then list, again call this, is 3 now because now sublist again. Then this is not a base case, A is equal to 3. Oh, sorry, it's a base case because the num dot size is equal to 0. I will say num dot size minus 1, or maybe you can say num dot size equal to 1, anything which you really love. Okay, so yes, this is a base case. If this is a base case, return that value. So I am returning this 3. Nice. Okay, what next I need to do? I need to make a new array list of answers. So for example, I created this. Then I am saying I need to run a loop. So it will take L is currently 3. Then I am saying answer, add in an answer. What I need to add? L dot add I. So what will be our I first? I is 0. N dot size is currently 2. So it will run 2 times. So when I is 0, I am saying add A at 2, A at 0. So okay, I will write this. L is equal to 3. Then I will start from 0 until 1. And now I'll do 1 by 1. So when I is equal to 0, I am saying L dot add at I A, which means go into the L, take 0 at 0, put value A, which is 2, and 3 is automatically pushed back once. Okay, then I is equal to 1. Now what I am saying, L dot add at I and A, but I this time 1, so I am saying okay, 3 and 2. And why it's not crashing? Because we are inserting consecutively. I am not saying insert something, because if I try to insert one more on the other side, it will be a crash because it's index out of bound. And in this case I am saying okay, insert or add one new in the end. So now I have these 2, these both are in the answers. So we have answer array which is written here. So now my answer written here is 3, 2, then 2 and 3. So this is our list in this case. Now we will trace this. Okay, I am removing all this because now it's in a stack we are here last time. Now what I will do, we have 2 loops. So first L will run for twice, one for 3, 2, and then the second time run for 2 and 3, and I will run until n dot size, which is 3 times. So I will run is equal to 0, 1 and 2. Okay, what I want, so first time we are saying it's a 2 loops. First time take 3 and 2, I took this, and now I need to run I loop. So I is saying L dot add, this is our L, add what? I is 0, at 0 what is A is 1, so I added 1. Okay, loop end. So this is I am going to add in answer. Next time again 3 and 2, I is 1, add 1, 1 A basically. Okay, done. Then second time again I need to run this 3 and 2. This time I is 2, so 0, 1, 2, add 2, but add A. What is A? A is 1. Okay, So this is done. Now next time I need to run this loop for 2, 3. So now we have 2 and 3. And now I need to run again I. First time when I run 0, it means I need to put at 0, 1, 2, 3. Next time I is 1 now, so when is 1, so I need to put 2 at 1 index and 3. Then I need to write at 2, 2, 3 and 1. So now this is going to return a whole answer which will contain these. So this is our final answer. So now we can try this algorithm. We try to write in a proper language. Done. So fun permutations, perms, nums, int array, and return, we need to return list of integers. Only one thing, I'm using syntax of Kotlin, but in Kotlin this will be a mutable list. If you are not aware of that, it's okay, treat this list, because in Kotlin list you can't insert or add anything once it's ready. So you need to make a mutable list, otherwise everything is good. Then next I need to do if nums dot size equal to 1, return nums. And basically it's nums is an integer array. This will not work. So what I need to do, I need to make a new list. So I will make a mutable list of, and then mutable again, mutable list of, and I can put nums at 0. So basically I need to return list and list of, and the value will be 3, the any value which is available at a 0 point. Or I can call directly maybe nums.toList. I think so toList is extension method is there, so you can make a mutable list of nums.toList, so it will return. Okay, now one more thing, okay, we will discuss that later. This is done. Next we'll discuss, I need to save my first index value. So I can say first index value, which is always nums of 0. Then lists. Basically here we need to call again our method perm nums dot split. I'm not 100% sure if split method is list split is available, or sublist is available in Kotlin, but for the time being I'm using this, assuming there is a method which is saying okay, you can give me the index and range. Okay, this is done. Then answer, which is again mutable list of integers. So in case of a Java, I will write simple list. Instead I will say array list of integer, new array list. So both are same. Cool. This is done. Then the simple calculation which we already completed, for loop for my all the answers which we have in list. Then I need to run the algorithm until nums dot size and now we need to play here with answers dot add. Then I need to first convert this L in the form of mutable list. So L dot to list, or I will divide into 3 so it will be easy to remember. Okay, so I will say value maybe temporary, convert this L dot mutable, to mutable list. So I took this list which is already mutable, but I am creating a new copy. Once I will insert, this will not impact the original one. Okay, temp, then temp dot add at I, my first index value, then add temp in answer, this is, and return answer. So this is our final algorithm, and it's pretty easy. Maybe you are feeling like it looks like now tough, but once you will start, try to break down your input, then take that until base case, then think, okay, once you are coming back from there, what you can do with that input to make the answer, and for that you need to do only this part as an algorithm. So this one is final. Any problem here? So yeah, this one is a mutable list of int. Sorry for that, the language, but when you are writing code in an interview, don't assume, don't ignore. It's very important to show them, hey, I am using this language and I really know this language. Okay, then everything looks nice. This one looks nice. This one I need to confirm how to sublist. Okay, what will be the time and space complexity? So time complexity is still big of n factorial, you can say, just like we discussed in the last video, because it's going to be n factorial. When you have 1 to 3, you need to make 6. When you have 4, you are going to make 4 multiplied by 3 multiplied by 2. So it's the n factorial. If you are going into detail, like you want to define, figure it out, the original value in the form of n, not a big O, then it's different. Then this will not be n factorial. This is more than that, but we are taking the benefit of big O value. So I'm saying, okay, big O of n factorial. And in case of a space, what we can say, it will go until the whole. So this is one is going to the big O of n. Simple as that. Because in stack, if I have 3 value, I will first stack, then move to the second, then the third, and then I am coming back. So that is the big O of n. But we are also taking care of a lot of space inside. We are making new lists which are temporary. So here we can discuss more in detail, but as generally big O of n should be enough. Okay, can we improve this algorithm? Yes. So I have a feeling what we can do. So most of the time this num and these operations are pretty expensive, and from the CPU perspective, it's the CPUs, we are taking a lot of CPU cycle. Take this array, then divide, copy. So I think if we can manage some kind of an index, don't send the whole num, send num, but don't do the sublist and send the index. So some kind of like, okay, if my algorithm is like, I am saying, okay, I will send you index int. So if this is my parameter, then I can check here also. You should go until num dot size is equal to index, maybe num dot size -1, and then this will be index. Then in this case, I'm not trying to do anything with the, I'm not going to break my int array into double sublist. I'm directly saying, okay, send these nums and index plus 1. So basically what happened, last time we took 1, 2, 3, next time I split this, next time I split this. But now this time I am saying, okay, this is my index. Next time when I am calling, I am saying, okay, you need to take care from this index. Then the last time when I am calling this, I am saying this is my last index. So basically what will happen, 0, 1, 2. So here I am saying, when num dot size minus 1, which is 2, is equal to index value, it means my base case. So from here I am saying I will only return one value in the form of a 3. Then we saved here, every time we are doing the sublist. Now we are not doing that sublist, it's a pretty big wing. Then what else? Then we have this mutable list of, every time we are making this new, then we need to run this in the list, and also this algorithm now change. So because last time we have 1, 2, 3, then 2, 3, and then 3. So if this is the case 2, 3, in that case we need to only run 2 times. But if I do this num dot size, it means it will run from 0 until 3 every time. So we need to do some calculation here. So I think so, if it's my last case, return here. If I have a 2, 3 case, so if this one is the case, in this case I need to run twice. What I can do, I can say, okay, num dot size, my index at this place is 1, so minus index minus 1. So in this case I'm saying, okay, num dot size is the original size, which is currently 3, minus index which I am sending, which is 1, 3 minus 1 2, and minus 1 is the extra, because I can say this is the algorithm, so it will be returned 1. And once my index is 0, so I am calling for this should run 3 times. So we can see num dot size, which is 3, minus index is 0, and then minus 1. So in this case it will run until num dot size, this should work. I think minus 1 is not required, so I have a 3 minus 0, so it will go until that. So if I have only value 2 and 3, so num dot size is saying I am 3 and my index is 1, so it's saying 2, 1, so this one should work. So it's very important, these edge cases I need to run, but I'm sure it looks like it should work. Okay, this one is done. Then we are doing here index, otherwise everything looks good. So by doing this, what we achieve, we are saving now no more CPU cycles for the sublist. From the space perspective, can we do something more? I think we can. The biggest users of the value is one is this. Every time we need to make a new copy, and we need to make, there is no other option, and then after that we need to add. So maybe we can play, don't go with the array list, we can go with the int of array. In that case, what will happen, in an interview it's okay to go with this one because it's good, you will save time. In case of int array, you need to write a lot of checks, but the benefit is here int primitive is of 4 bytes. In this case, this is the Java object, which is around kind of a 16 bytes as per my knowledge. So if I play with only array, then I can save, algorithm still same, but I can save a lot of value, the bytes, because 4 and the 16, it's a 4 multiplied by 4, so I can save 4 values in this and 1 value in this as an object. Still good. So I hope today I shared something new with you guys. So always remember, every time when there is a recursion question, try to make a tree just like we did in the first video, and once you have a tree, then make a complete tree, write the algorithm and try to convert that complete tree algorithm in the form of what is the ask. Or you can take the input and then try to divide that input one by one, and then recursion's power, it will come backtrack. Once it's backtrack, try to put that your mathematical calculations or algorithm how you can make something which you want, and by doing this you can achieve easily. Don't memorize, do practice every time when you have an input, and you can apply this same technique on multiple questions. We will do more questions around the same thing, and we will use again the same both these techniques. Okay, so thank you for watching. See you in our next video. Bye.